Okay, these are the notes for day 12, our last day on Trig. And we're going to talk about something new here at the top, but it's actually a really easy process. But before I actually jump right onto the notes, I want to kind of explain what we're going to talk about. In geometry, we talked about angles, and our angles often look like this. And this right here was the measure of the angle. And we know that an angle that looks like this, well, that's 90 degrees. And an angle that looks like this, that's 180 degrees. And if I take an angle and I start here and I go all the way around to here, that's 360 degrees. But can I have an angle bigger than 360? When might that happen? Well, what about if we're talking about a wheel? Here's a wagon wheel. And I want to know how far this point right here turns. Could it ever happen that it turns more than just one full revolution? Sure, it could go 1.5 or 2.5. And we can use measures of degrees and radians to tell how far it goes. So for instance, if I start here and I go around one whole time, and I go around another whole time, how far do you think that is? Well, the first time I go around from here to here, that's 360. And then when I go around another full time, that's another 360. So 360 and 360 makes 720. And that's the idea we're going to look at today. We also have, because we set our unit circle up where this was 0, and we always measure our angles going in this direction, what happens when we go the other way? Well, the way we've set it up is that if I go the other direction, these are negative angles. So for instance, if this is negative 30 degrees, this line is in the same place as if I went 330 degrees this way. If I add these together, do I get 360? 330 plus this 30 makes 360 the whole way around. So this angle, negative 30 degrees, and this angle, 330 degrees, are really describing this same angle here, just going from two different directions. So that's what we're going to talk about in the first part of our notes today. Negative angles and angles that are bigger than 360. So we're going to call reference angles to be our angles that are included on our unit circle. Namely angles between 0 and 360, or between 0 and 2 pi radians. And to get a reference angle, all I need to do is add or subtract multiples of 360 or 2 pi if I'm working in radians. And does that make sense with what we were looking at here? If I start with 720 and I subtract 360, I get that this angle, 720, is the same as an angle of 360. Here, if I take negative 30 degrees and I add 360, I get that the rest of that angle is the same as the angle 330. That's all we're saying. I can either add or subtract 360, and I might have to do it more than one time, but I'll eventually get back to my angle that I see on my unit circle, being between 0 and 360. Okay, so let's look at some of these. The first ones here are in degrees, because I think we're more used to those. So the process is the same. I just take this number, and if it's bigger than 360, I subtract 360. Well, what is that? Well, that's 240 degrees. So 600 degrees is the same as 240 degrees. 450, subtract 360. 450 minus 360, that's the same as 90 degrees. If I have a number that's smaller than 360, like negative 300, instead of subtracting, I'm going to add 360. Negative 300 plus 360, that's 60. Okay, negative 900. Well, when I add 360, I get -540. Oh, but that's still smaller than 360, so I'm going to add 360 again. When I add 360 again, let's see, 14, that's 80. Take 1 from there, that's 4, 180, -180. Oh, that's still less than 360. So I'm going to add 360 again. -180 plus 360, that gives me +180. Ah, there's the answer. -900 degrees is the same as +180 degrees. Now 180 is on our unit circle, and I could look up the sine, the cosine, or anything else I need to know about this angle. Okay, now let's look at some pi's, some radian degrees. I think in some ways these are easier. 360, if you want to look at multiples of 360, you have 360, 720, and they kind of get hard to remember. Multiples of 2 pi are very easy. Multiples are 2 pi, 4 pi, 6 pi, 8 pi. And I could actually subtract a multiple of 2 pi that gets close to this number. But first let me do it just kind of like I did this one here. So doing it like this one, I would subtract 2 pi and get 7 pi. Not close enough yet. Subtract 2 pi and I get 5 pi. Not close enough yet. Subtract 2 pi and I get 3 pi. Still not close enough yet. Subtract 2 pi and I get pi. Finally, on our unit circle. Could I have gotten the same answer if I just used the multiple of 2 pi, that's 8 pi, and done 9 pi minus 8 pi? We'd get the same answer. Now, the only trick when I actually have fractions with my radians is I have to think in multiples of 2 pi. So 2 pi is the same thing as what with the denominator is 6? Well, 2 pi is the same as 6 pi over 3. So I'm going to use the 6 pi over 3 to add to this, because it's the same as my 2 pi. Well, -1 pi plus 6 pi makes 5 pi over 3. Just our plain fraction rules. The next one, 20 pi over 3. Okay, that's still going to be 6 pi over 3, so subtract 6 pi over 3, and I get 14 pi over 3. Do it again, and I get 8 pi over 3. And I have to do it one more time, minus 6 pi over 3, and I get 2 pi over 3 as my final answer. What we're saying is 20 pi over 3 is the same angle as 2 pi over 3. Okay, now we have a different denominator. So what am I going to use this time? Well, this time instead of using 2 pi equals 6 pi over 3, I'm going to use 2 pi equals 8 pi over 4. And I'm going to add that on here. -15 plus 8. That's -7. Still not good. Still not close enough, so I have to do it again. So I get pi over 4. Pi over 4 is on my unit circle. Now I could take and use sine, cosine, tangent, whatever I need. What we're saying again is -5 pi over 4 is exactly the same as pi over 4. These two will have the same sines, the same cosines, the same tangents. Okay, and my last one here. Now I've got a denominator of 6. So I'm going to use 2 pi equals 12 pi over 6 as my factor. So I'm going to add 12 pi over 6, and I get -13 pi over 6. Not on my unit circle yet. Add another 12 pi over 6. I get -1 pi over 6. Close to my unit circle, but still a negative angle. So add 12 pi over 6 one more time. And I get this is the same as 11 pi over 6. So what I've said is this angle, -25 pi over 6, is the same as 11 pi over 6.